Hello everyone. Today we are going to discuss about the sorting. And before video, we have discussed about what is topological sorting and strategies or steps used in topological sorting. And step one we have discussed. First, as a step one, we have to identify the incoming edges of the each vertices. So that is the first step. We have seen that in earlier video, and now we are going to see the second step. So here, so in before as first step, we have identified the in degrees of each node, right? For A's in degree is 0, B's is 1, C is 2, D is 2, and E is 2. So what is the next step we have to perform is uh, we have to find the least in degree vertex. Okay, the vertex which is having minimum, that is least in degree value. So in this graph, A is having least value, that is 0. Okay, so we'll pick A first. We have to remove this A. Okay, we have to remove this vertex A from the graph. So that is the next process. So as we discussed, I have removed this A, that is a vertex A, from the graph, and the resultant graph will be like this. After the removal of the node A, my graph resembles like this: B, D, C and E. And we have to keep this A in a separate, as separately. So again, once if you remove the vertex A, again we have to calculate the in degree for each of the vertex or each of the node in the resultant graph. So this is my resultant graph. So I will calculate the in degree for each node. So just see the previous graph, that is this one. So here the in degree of B is 1. But what about in the resultant new graph? In degree is 0. Okay, so once if you remove that vertex A, obviously what happens, the edges of the vertex will be removed, right? So here I have removed the edges also, that is the links also. So that results in changes in the in degree. So here B will be having 0 and D will be having 1 and C will be having 1 and E will be having 2. So this is my final in degree. So as step 3, so vertex B has the least in degree. Now what I have to do, I have found the in degree for the each vertex, and then what I have to do is I have to repeat this process. Find the in degree of each vertex. So this is my in degree, and which one is having least in degree now? B is having least in degree, that is 0. Okay. So here I am just removing the B from the graph and updating with the A to B. Okay, I am removing A now, and I am removing B also. So when I remove this B vertex, what happens? This both edges B and C will be removed, right? uh, yeah, both C and D edges will be removed. So my final graph will be like this, C, D, E. So this is my final graph. So I have to perform again, I have to calculate the in degree, and I have to see which is having the least in degree vertex. So here this is my resultant graph now, C, D and E. C is having 0 and D is having 0 in degree. What I have to do, I have to choose any one among these two vertex, C and D. Okay, so as of now we have A and B vertex, and now C and D is there having 0 in degree. What I have to do is I have to choose either C or D. So in case 1, if I choose C, which means if I remove C, what happens? D and E will be remaining. Okay. The same way from this graph, if I am choosing D, if I am removing D, what happens? E and C will be remaining. Okay. So likewise A, B. So in case 1, if I am doing case 1, A, B, C will be the resultant vertex, and for the second case, case 2, A, B and D will be the case. A, B, D will be the topological ordering. So next is the same way. If I remove everything, having 0 in degree, finally I will be getting A, B, C, D and E. If I choose C first as C vertex, or else in case 2 A, B, D, C and E. Okay, so this is also a correct topological ordering. Both are correct. Okay, so based on the in degrees, we are calculating the topological ordering of the graph. So once if you are having 0 as in degree, so that is considered as the least incoming, in degree of the vertex, and we are removing it from the graph. Okay, the same way we are repeating this process till we process all the vertices. Thank you.